So we're finishing up on transformations of functions. I wanted to do a few more examples before we moved on. So right now you should be seeing a picture of a graph in front of you. And we're going to take this graph, and depending on what they ask us to do to it, we're going to make some transformations. And so let's say for part A, they tell us to look at what is, and let's change color. Let's do f of x plus 3. We're just going to start easy. Okay, so remember, transformation of functions, it depends on, are you adding something outside of the function, or are you adding it inside where you're affecting either the y value or your x value? Outside affects the y value, so it increases or decreases. And there's nothing inside here, so our x value is going to remain the same. And so I know that any point that I have xy on f of x, to get my new point, my x value is going to stay the same, but my y value now, I'm going to add 3 to it. So I would just go through and, well, this one wouldn't be too hard to do, so let's just do it without graphing it up. So all we're doing basically is taking these points and shifting them up 3 units. And so my y value at -2 is going to go up 3 units, so we're going to hit at y value of 1. So -4, 1 is our point. Same sort of idea at 2, -2. If we shift it up 3 units, we're going to have a point at -2, 1. Our origin here, that was at 0, 0, shifting it up 3 units, gets us here at 0, 3. The point here, that was at 2, 2, shifting that up 3 units is going to get us at 2, 5. This point here at the origin is now going to shift up 3 units. And this point at 4, -2 is now 4, 1. So this is our f of x plus 3. So what if it said f of x plus 1 and then -2? So we talked about order mattering when we were doing transformations. So always work with the horizontal shift first. Horizontal shift is the number that we're adding inside. And so this was the opposite. Kind of try to think about what you would have to do to get x by itself in here. You'd have to subtract 1. And so that's what we're going to be doing. We're going to shift x to the left 1. And then the -2 shifts it down 2. So we could look at our point, xy, determine what you're doing to get your point on f of x plus 1 -2. Well, the x values, we said shifted to the left 1. So that's subtracting 1. And so my x value is now going to be x minus 1 from my point. And my y value, I'm shifting down 2. So I'm taking away 2 from my y value. So y -2 is my new point. So you could just go through if you wanted to and list your points. We have one at -4, -2. So if we add, subtract 1 from -4, that gets us a point at -5. If we subtract 2 from -2, we get -4. So our new point here is -5, -4. So my point, that was at -2, -2. Well, I'm subtracting 1 from my x value, so -2 minus 1 is -3. And I'm subtracting 2 from my y value, so -2 minus 2 is -4. So instead, we have a point here at -3, -4. Your origin, 0, 0. So left 1 is -1, and down 2, so -2. So we have a point at -1, -2. Our peak there, which was 2, 2. Becomes subtract 1, 1, and subtract 2 from the y value is 0. So 1, 0. And then the last point, 4, 2, subtract 1. Sorry, 4, -2, subtract 1, so that's 3, and down 2 is -4. And so this one was the f of x plus 1, and then in parentheses -2. Let's do one more. What about the f of -x? So what is that negative doing in front of the x?
Is it going to shift the whole thing to the right one?
The minus right in here?
Yeah, because would it be treated as a -1? Oh, I guess it wouldn't. Never mind.
No.
Is it a reflection?
So reflection across what?
X-axis?
Okay, so if you're changing, so think of it this way, and this is where I was like, okay, let's just think about on the coordinate plane. So basically this negative is changing the sign in front of our x value. So if we're changing the sign of our x value, so just kind of choose a point that's x. So let's say if it was at x equals 2, now the x value changes sign, it's going to be -2. And so that's actually a reflection across the
Y.
yeah. So it's a reflection across the y-axis. And that's what I just have to look at. Am I affecting my x value or a y value with that negative sign? And then I just have to think about, okay, flipping my x sign, that's the y-axis. Where if the negative had been in front of the f of x, that's saying that we're changing the sign of our y value, and changing the sign of the y value reflects it across the x. Take over. Maybe I can get rid of that blue dot. Okay, so this negative, this flips the graph. Across the y-axis. Or another way to say it, it's just a reflection. So if I look at this black graph and I just start doing a reflection. So I'm just going to just change my x signs. So this point here, it was at -4, -2, is now at 4, -2. This point here that was at -2, -2 is now at 2, -2. There's a horizontal line in between it. This point at the origin is still at the origin, right? Changing 0 doesn't do anything. And this point here that was at 2, 2, just change our x sign, that's going to be at -2, 2. And then what else do we have? This point down here that was at 4, -2 is now -4, 2. Okay, so this is the reflection of the black graph, f of x is in the green. Oops. Okay, so you should be able to take a graph and then perform transformations on that graph and graph the new graph.
If we had a negative function instead of the negative x, would that just change the y values and make it reflect over the x-axis?
Exactly.
Okay.
And so you're right. So we could just do that too. So negative f of x, this is going to be a reflection across the y-axis. It's just changing the signs of our y on the graph. So reflection across the x-axis. And so we could just start taking points. I don't know if we want to do a different color. And just because it's getting so crowded over there, let me just regraph it really quick. So looking at f of x here, and if we looked at negative f of x, so I'm just changing my y sign. So when my point was -4, -2, it's now -4, 2. That's point -2. -2 is now -2, 2. My origin is going to stay the same, change in 0. The sign of 0 is still 0. Here at 2, 2, it's now going to become 2, -2. And this point here at 4, -2 is now 4, 2. And then this is 3, 0 is still 3, 0. Okay, these were kind of interesting too. Suppose a function f of x is decreasing on an interval between -2 and 7. So we're given that f of x decreases on the interval. So this is all the x values, including -2 to 7, including. So knowing that, we should be able to answer the following questions. So over what interval is f of x plus 2 decreasing? So what do you guys think? That plus 2 in there, what is that doing to the graph?
F of negative x.
There's no negative. Oh wait. Maybe I'm misunderstanding what you're saying.
I was trying to change the -2 to a +2 by doing a f of negative x to reverse it.
So think about for inside, when it's inside like this, think about what you would have to do to get x by itself. What would you do if you wanted to get x by itself? If you had x plus 2 equals 0.
Subtract 2.
Yeah, subtract 2. So that's what we're going to do here. So we're just basically shifting things to the left 2. So we're moving 2 units this way. So basically, when we have a graph that's going downhill, starting at x equals -2, so there's some -2 here, to x equals 7, it's going to be going down. So if I shift everything to the left 2, right, that would shift this piece over 2 units. So this is now going to be 5, right? And this would shift this dot over 2 units. So that would be -4. So if I did that, I have something like this. Oops. And so now it's decreasing on the x values from starting at -4 and going to 5. So same thing, it's decreasing from -2 to 7, but over what interval then would f of x minus 5 be decreasing? F of x minus 5 decreasing.
Would that move to the right 5?
Yep, so it's moving to the right 5. And so if we started at -2 and went to 7, what is our new interval? So originally it was from -2 to 7. Where is our new interval where it would be decreasing if we shifted everything to the right 5 units?
-2, 12?
-2, 12. You're right on the 12, because this is really an x value. Don't think of this as a point. That kind of looks like a point. So this is a range of x values. So we have to actually shift the -2 also over 5 units. So to shift this over 5 units. So if we add 5 to -2, we get 3. And then if we add 5 to 7, we get 12.
So in these problems, we're trying to figure out the domain, right?
It's not asking for the domain. It just wanted to know, okay, if we have a piece of the graph that we know is decreasing at a certain interval, in this case between x equals -2 and 7, what do we know about the piece of the graph when we start shifting it? So if we shift it left or right, notice that where it was decreasing originally is going to be changing our x value where it's decreasing. And then in here, like if you put a negative in front of it, so it says, is the graph y equals -f of x increasing, decreasing, neither on -2, 7. So let's look at that. So is the graph y equals negative, so putting a negative out in front, f of x increasing, decreasing, or neither. On negative 2, 7. Okay, so what is that negative? We got to think again about what the negative is doing. So this is a reflection where,
X-axis.
right? So this is a reflection across the x-axis, changing the y value. So if I took this black graph, or that line that was just decreasing from negative to 7, and I start flipping this across the x-axis, it doesn't really matter where my line is, but just to give you a visual. If I start flipping this across my x-axis, I lost it. Then this point here is going to be flipping down here. And this point here is going to be flipping here. A mirror image, right? And so what's happening then at the graph between x equals negative 2 and 7 when we reflected it? Is it increasing, decreasing, or neither?
Increasing.
Right, so we're increasing then. And one more is the graph of y equals f of negative x, increasing, decreasing. So the graph y equals, if we put the negative inside, f of negative x, increasing, decreasing, or constant. Or neither, I guess, is another way to say it. On negative 2, 7.
So it's increasing again, right? Because we read left to right.
Mm-hmm. I got to actually think about it. So let's think about it. So let's say, well, if this is negative 2, I would have like an x-axis or a y-axis there, right? And this is a reflection across the y-axis. I think you might be right. So this point here, right, is here. This point here would be over here. And so a reflection, it's going to be and I wrote this down wrong. It said on the interval negative 7, 2, because I was going to say something's wrong, right? Because this is really our x value 7 changed to negative 7. And this x value of negative 2 changed to 2. So I'm thinking, oh no, something's wrong because I don't know exactly about that piece. But so this interval said negative 7 to 2. And it looks like it's increasing. So good problems. They kind of help you think about what's going on and how you're shifting and what these values inside are telling you to do to your graph. Let's do one more. So I like this program just because I like the way that it feels writing, and I like it's easier to get to the pens and change colors than the OneNote, but it tends to like shift all of a sudden. And it's hard to get it back. And that's a little annoying. Okay, you have 1 point on the graph of f of x, and you know that 1, 3 is a point. So this is a point on f of x. Totally different problem than we just did. And so what would the point then be? On f of x plus 3. And then in that parentheses minus 5. Think about it, see if you could figure out what that point would be. So this would be an example, like on an exam, instead of just giving the point, because if you're wrong and you just give me the point, I couldn't just give you partial credit. But if you had told me stuff about what's going on with this, I could give you some partial credit. Like if you said, hey, well, I know this plus 3, this is going to shift it where?
To the left 3.
Yeah, so the left 3. So basically, I'm going to have to take my point that was originally x comma y. Oops, comma y. This is going to be left 3. So I would have to take my x value and I would have to subtract 3 from it for my new point. And then the minus 5 is what?
Should be a plus 5 now, right?
Same idea. It's actually, if it's outside, it's the same direction. So if it's minus, it's going to go down. So this will be down 5. Think of f of x as your y value, and your y value then is subtracting 5 from it. So it's then down 5. So it would be y minus 5. And so that point we were given, 1, 3, we just figured out the formula to get the new point. So 1 minus 3, that gives me a negative 2. And then 3, my y value minus 5 also gives me a negative 2. So if I had the graph and it told me to shift and graph f of x plus 3 minus 5, I could be using this to help me get the new points. What if it had been negative 2? Then f parentheses x minus 2, and then plus 1. So again, order matters. Here, the minus 2, that is telling us right 2. Vertical shifts are the last thing you do. And so what is that minus 2 doing to this? Is that affecting the x value or the y value of your point?
X?
Both.
Isn't it a reflection over the x-axis?
You're right that it is a reflection over the x-axis because of the minus sign. Oops. So because of the minus sign, it's going to be reflected across the x so that is affecting your y value of your point. You're flipping the, over, changing your y value. And this 2 is also being multiplied by your y value. So this is making it decrease or increase at a faster rate, the steepness. So we're going to take our x value, xy. We said that we were going to add 2 to the x value because we're moving it to the right 2. So we're going to have x plus 2. First thing you have to do after you shift left or right is reflection and stretching, which is this -2. And that is affecting the y value. So we're going to take -2 and we're just going to multiply it by y. And now we can look at the +1. So +1 shifts it up 1. Shifting up 1 is affecting the y value, so you're adding 1 there. So we just came up with a formula. So our point that was at 1, 3 on the original graph is now going to be at, we'll add 2 to your 1. And then we're going to take -2 times our y value. Our y value is 3, and then add 1. So we have a point at 3, comma, -2 times 3 is -6. -6 plus 1 is -5. Okay, so our new point is 3, -5. Okay, so that is 3.5, so transformations of graphs. I'm going to stop the video and then I'm going to restart it with a new one. So the video isn't as long.